Another shaders that let the light to pass through a surface are a translucent and subsurface scattering shaders. Let's add the translucent shader. We can see how light is scattered inside the mesh, but to see the results even better, we will turn off the HDRI by going into Word Properties and changing Strength to 0. And we'll add a single point light. As this shader was created for thin objects like leaves or paper, let's create a simple plane. When I'm moving the plane towards the light, we can see that the surface which is facing to the light is very dark and the opposite is way lighter. It's acting like an inverted diffuse shader. It lets the light go through and is called a diffuse transmission. We don't really want to use translucent shader on its own, but is accompanied by the diffuse shader very often. Let's mix the translucent shader with the diffuse one and try to make a paper-like material. When we set the mix value over 0.5, the surface which is facing the light is getting darker because it's more translucent and it's letting more light through. This is not particularly physically accurate because as the translucent shader mimicked the paper or leaf material, it is better to keep the mix value at a maximum of 0.5 to let some light be reflected from the surface facing the light. If we change a diffuse color to off-white and translucent to something similar, it looks almost like a sheet of paper. The light goes through the surface and we have a nice light gradient at the bottom of the sheet. And now some examples. Next shader that lets the light to pass through and scatter it inside is a subsurface scattering shader. It is more complicated than the translucent shader and it works best on thicker objects. It allows light to pass through the whole objects and bounce inside. Remember the example with the light in your hand? That's exactly what this shader is doing. The default settings are to mimic the skin, but to get the best results, we need to change the method to random walk skin. It modulates the radius color based on the main color, anisotropy, and IOR. The scale value describes how much of the light is passing through, and the radius color describes which one of the three, red, green, or blue, is able to travel the most. Let's change all the values to 1 and main color to white, and we can see that everything changed to white now. Although everything looks very smooth, we still have nice visible edges thanks to the random walk skin function. We can see that changing it to Christensen-Burley almost completely removes the edges, making the object too smooth, but it's a bit faster. We'll stick to the default option, which is random walk, and when you will need to create a skin-like material, use the random walk skin function. Before the next lesson, try to make a candle material using the shaders you already know.